Hey everyone, it's Sam the Reclaimer developer here, and a lot has happened since the last devlog, and it's primarily been work on the main character and the memory management library. But before I jump into the game and show the main character's placeholder, I wanted to just go over the main character's appearance, why he looks the way he does. So in the game, the main character is a soldier, and he was put into like cryostasis during like right after the Cold War era. So like I think early to mid '90s, and so he's gonna wake up and be outfitted with like this is probably an example. This is just like a picture of a toy, but he's got military garb. He has a gun. And his most noticeable feature is going to be a gas mask that looks exactly like this. I don't think he's going to have the poncho, but this is just sort of the basic look that I'm going for, just like a chemical weapons soldier kind of look. But under his armor and everything, he is just going to be absolute nightmare fuel. So, very Robocop esque. He is a clone that has been pretty much dissected and very brutally put into a cyborg body. I mentioned in my intro devlog that the character is going to be outfitted with an exosuit, and I'm taking a little bit of inspiration from Elysium, and I'm also just looking at how just sort of inspiration for what I want his exterior and interior to look like. His head is just basically a skull with some cybernetics strapped on, and on the exterior, like this is an asset I think from Killzone 2 or 3. But sort of how you see those red eyes, and it looks like there's like a closed circuit rebreather coming out of his mask, and I wanted the character to be fitted with a rebreather. This is a picture of a rebreather I found online. What I want his prosthetics to look like. I mentioned the inspirations are just kind of all over the place. I'll put these together in a more presentable format. This is the look I want him to have just looking at him head on. So he's got his military garb, he's got his gas mask, and he will have a helmet, and but he's just really off-putting just under the hood. Just sort of this air of, I don't know, like a mixture of like horror and like sadness just kind of all rolled into one. But anyway, let's go ahead and close all of that, and let's just go ahead and jump straight into the game. So I'm going to go ahead and launch our dev shell and launch our editor here. So, quick disclaimer. I threw together a basic model in Blender that's very blocky, very Minecrafty, and we're going to see what that looks like here shortly. And you're going to notice right away he looks like a couple of familiar characters. One is he looks like a Spartan from Halo. He kind of looks like the Master Chief with the very blotchy programmer art I have on his texture. He looks kind of like a creeper from Minecraft. I know. Everything you're going to see is a placeholder. Like, this is not indicative of final product. I just have something there that is proportional to what I think the player character should be, and just something in place to help me get a third-person camera and basic user controls working. So let's just go ahead and run this. And so there he is. The main character's name is Adam, and there he is in all his glory. And like I said, he looks kind of like a Spartan, kind of like Master Chief from Halo, and his chest here, his art looks like a creeper from Minecraft. That is not intentional. It is purely coincidence, but like I said, a lot's changed. The cube is gone, and the basic scene controls for the camera has been updated quite a bit. I can now click and drag the screen around, and the camera controls in terms of rotation are a lot more sensical than they used to be. I added mouse scrolling to where I can sort of zoom out and zoom in, rotate around. The math library, it used to be just... It only had the ability to rotate on a global axis. So, like, when I wanted to rotate up, it would always rotate up in the same direction on, like, this axis right here, and the same for the z-axis right here. So now I added the ability to just define an arbitrary vector and rotate the entire image around it. So that's basically from a user standpoint. We went from basically nothing to still basically nothing, but just a little bit more. And I also sort of started to refine the debug controls. The FPS is all over the place, and I think that's just because of mostly OBS is probably stealing resources from the machine that the Reclaimer would like to use. But I'm using a studio tablet monitor because I wanted to just do a little bit of note-taking as I illustrate things that are going on in the code. So the FPS counter is all over the place. If I were to click and, like, drag, yeah, it's not very good. When I'm not running OBS, I can probably get around, and I'm using my other monitor, I can get, like, 120 frames per second consistently, and on my laptop, I've gotten probably over 1,000 frames per second. But there's a lot going on this machine. It wasn't originally built for gaming. It was originally built for video editing, so I don't have the best equipment here on my streaming station. I'd like to do a setup where I can stream from a separate laptop through a capture card, and that should speed things up a little bit. And let's see. I also have this is like the demo window for I'm GUI. And none of this is properly working. Like if you saw, like, in my branch, it's debug camera controls. I'm just working on some basic controls to control the camera, and you can see, like, it's not properly working. I'm still debugging some stuff, but just the ability to drag things around. My end goal is to, like, if I were to have a camera behind Adam that would act as the third-person camera, the camera that's active right now is the scene as the debug camera. So, like, this will be a camera that, if the game is in debug mode and I can use the debug tools, this is always going to be present. I can just switch to the debug camera, drag the scene around as I have to. I can add more debug cameras if I want to see, like, things from an enemy's standpoint, or just attach it somewhere where I just want to have a different vantage point as things are happening, as things are playing out in the scene. But the idea is I want to be able to draw some debug geometry that would represent a camera, and I can just click and drag it and adjust it and switch to it without having to just constantly kill the program, update the code, compile it, and run it. So basically be able to save camera configurations on the fly. But that's basically it from an update standpoint in terms of the features that you can see. But let's go ahead and kill the code and kill the game, and now jump into the code. So let's just go ahead and kill the terminal and bring up. So the most significant part of this that I added, if you notice that there was a like memory usage statistic, and that is coming from this library, which is the new memory management library. So in this version of the Reclaimer now, there is only, we allocate all the memory up front. So we make a single call to Windows to virtual allocate a block of memory, and currently we are asking it to allocate 2 gigabytes. That's not a whole lot of memory, like, especially in terms of, like, modern games today, but I expect that it's probably going to rise to 4 gigabytes once a lot of stuff starts to get added to the game, as we get, like, more assets, as we get more systems that's definitely going to increase quite a bit. So let me see if I can find where, yeah, the core memory size right here. So we initialize the memory and pass in a 2 gigabyte. We say memory library, give us an allocation of 2 gigabytes, and so it will call Windows, and Windows will call virtual alloc to give us a virtual allocation of 2 gigabytes. Let me see if I can, is that in here? Yeah, and this is basically all that it is, virtual alloc, and it's going to commit it and return a pointer to that memory. So actually, let me go ahead and jump in here again. And so you saw that the core memory size was 2 gigabytes. And if I were to pull up the debug tools, let's see, game status, you see that there's like 90 megabytes out of 2 gigabytes being used, like 4.84%. If I go to the task manager and we found, here's the reclaimer, it's using about 142 megabytes. So pretty close. There's like a bunch of other things, statically allocated arrays and things like that, that are bumping up the memory usage that I haven't, that I'm not allocating through the main library yet. But let me go ahead and go to the details for the reclaimer really quick. And let's see. If I go to details for the reclaimer and expand this, there's usually a place where we can see, is it the resource monitor, overview, the reclaimer, where are you? But I'm not sure where it is, but you should be able to see where we have our 2 gigabyte page that's allocated to it. And I'm just trying to find that really quick, so my apologies. But essentially, virtual allocation says, like, you can allocate however much you want up front, and Windows will say, hey, this the committed size is X, but the actual size used is Y. And so when you pull up Task Manager, it's going to show the actual usage that it's taking up, which you saw is like roughly like 150 gigabytes. I do sincerely apologize for the dead air. I can't seem to find it. There we go, the committed size. So here's our 2 gigabytes, and here's our, it shows like how everything else is being used. If I just go back to the task manager, you'll see how that works. So I can use everything. I can use everything in that pointer that Windows returned up to 2 gigabytes, and it'll be fine. So that's just a way that I'm just not robbing the operating system outright of 2 gigabytes, reserving it and say, hey, this is my memory, nothing else can use it. I don't have terabytes of RAM, obviously, but I could say, give me 2 terabytes of RAM and virtual allocated, and it'll do it. But eventually Windows is going to say, no, you can't do that. You've exceeded, the size of that you can use. But anyway, let's go ahead and take a look at the main memory structure. Whenever we allocate the memory, the pointer is initialized to this structure right here, reclaimer memory. So in this mem data here is essentially just like it's an alias to like a void pointer, basically. I prefer to think of memory as arrays of bytes. So instead of just like flat out pointers to void, I like to just reinterpret most things as pointers to bytes. So just most things when I'm adjusting pointers is going to be reinterpret cold casting things to bytes, so unsigned chars essentially. But this is our main reclaimer memory structure. We have our core memory, which is our 2 gigabyte pointer. We have and everything else is pretty much just a way to keep track of the alignment. right? We have the total memory size, which is going to be 2 gigs big, how much we have actually used, where the end address is, so basically wherever the address of this 2 gigabyte pointer is, plus 2 gigabytes worth of data, whatever that end address is. I don't think I'm going to be keeping all of this in the big, like, a lot of these things are probably going to be removed as time goes on, because I really don't need all of it. It's just mostly stuff that helped me keep track of alignment while I was debugging it. But the key thing about how this is used and how we allocate stuff from that core memory is this concept of a memory block. And so there are 2 double linked lists that point to the next element and the previous element. So there's the occupied blocks, which is every time I call memory API allocate, it's going to pull from this from the free blocks, and it's going to say, here is your memory from this starting address to this starting address based on the size that you requested. And it's going to give me that back, and I can do whatever I want with it, and I call, free, and it goes back into the occupied blocks. So let's just go ahead and take a look at how that works. So this is probably the most cumbersome library in the game so far, because everything has to be perfectly aligned. There's not really room for any mistakes here. And in order for things to work properly, and it's just very mathy. It's not the cleanest code, but for as of right now, everything's working. This was just a bunch of assertion code just to make sure that everything was lining up. But we essentially have, it's a linked list allocator, and everything in it is a variable size. So essentially, your free blocks are going to be, you have a free block that's pointing to the next free block that's pointing to the next free block. And if you were reading the list in reverse, it would be pointing to the previous free block, the previously block, and the same thing for the occupied blocks. And when you free a block, how we handle fragmentation is that it tries to find, I've got a chunk of memory that is being put back into the list of free blocks. If I find it, I'm going to put this back exactly where I got it, and if there's free blocks that are contiguous space, it'll just consolidate them. So if I have 2 blocks that are right next to each other, it'll just combine them. And the same goes for other blocks that are around it. So it's not a perfect solution, and I haven't tested all cases. I know this doesn't work 100%. It's just a way to sort of stave off just a simple starting way to address the problem of fragmentation. Because when you are working with allocation sizes that are all different, so this asset, Adam's placeholder asset is going to be a different size than the the skybox assets. And so what happens is you have these holes in the memory. So if I were to have, here's my 2 gigabyte chunk of memory, I'm going to allocate, here's Adam's asset, and here's, the skybox asset. And this is not to scale, obviously, but, this gets freed up, and then this gets put back in. And so more things get taken out. And so eventually what's going to happen is you're going to start getting these small holes in your memory that nothing can fit in, right? So eventually things are going to be so small that whenever you call, hey, memory API, allocate me a chunk of memory, this guy right here can't fit anything. And so the problem, that's called fragmentation. And so when you run a defrag on your hard drive, essentially that's what's going on. And so the way that I've tried to address this is when you free something, it tries to put it back exactly where it got it and try to look at the other blocks around it. So for instance, if I were returning this block right here, it would see, and I'm gonna go ahead and erase this and this. like, and let's just use blue for free block. If this is a free block and this is a free block and you're returning this, what my at least initial attempt is that it will see that all of this is, continuous memory, and it'll just make it one big free block. And so, it would be joined with this free block. And so it tries to, it's a very elementary way of addressing fragmentation. It's not perfect, but it's just a simple way to start. And that was why I wanted to, draw and show some notes how I was doing that. And how I'm returning things is you essentially are returned a handle, which is an index in that big 2 GB array. So let's go ahead and go back to this and I'll show you how it works. So essentially here's our 2 GB array, right? Or 2 GB pointer. And so remember how I said I like to see things as an array of bytes. That's like the smallest unit of memory that I can work with. So if you were to expand this, that means it's an array of bytes that is 2+ billion elements wide. It's really, really big. And so where each one of those starts is like element 0 in this array is the pointer to that memory structure that we saw. And it just sort of allocates things off the tail end as it goes on. And what the handle is, you're going to see the word handle decorated throughout the code now, and the handle is basically an index, right? And it's just an index to the exact spot for the first byte of your allocation. And so instead of passing pointers, I'm just passing indexes to that array. And I haven't run a profiler on the reclaimer yet. That could be a really bad way of handling things. Like, I know it's not the best way. Like, there's always a better way of doing things. But that's just I wanted to experiment with the idea of using handles to things so that, each system manages its own memory space. And like going back to that problem of defragmentation, let's go ahead and redraw, our 2 GB array. So, this is the beginning and this is the end. And so how this would work is essentially memory starts, game startup, give me the 2 GB. And so the asset system would say, hey, I need this many bytes to do my work. And then the rendering system, these brushes are not the same size. The rendering system would say, I need this much, and then so on and so forth. And so inside of that, each system is going to be responsible for its own memory space. And you just pass handles to things that you want it to update or delete or, just do your basic read-write operations on. And, that way things are, it's my way of sort of starting to think about data containment, which is how I wanted to think about this. This layout kind of reminds me of a Turing machine, just sort of where you have this theoretical computer that is, just like, I know this is like completely off topic, but, the original concept of a Turing machine was that you have this tape drive, this, tape of arbitrary length, and it's, in theory, it could be infinity. This could be infinity wide, and you just have this reader, aka just a pointer, and there are instructions and data that are filled out on this drive, and there could be section alpha, section beta, section gamma, what have you, and this reader just goes back and forth along this tape drive, picking up instructions, storing things in memory, and it's how I'm just thinking about things in that I just have a single call to the operating system to give me memory on startup, and then I return it when the game shuts down. There is no references to new, delete, malloc, free. There's only a single call on startup to allocate and a single call to deallocate on release. And so every other reference you see to reclaimer memory allocate, reclaimer memory delete, that is just working with that massive 2 gigabyte data structure, or that massive 2 gigabyte pointer, and it's just partitioning things from it. And so it's only 2 gigabytes. Like I said, it's probably going to be increasing later, but it's just my way of trying to compress as much as I can into the smallest possible space. And again, this is probably not the best solution for things. It's just where I'm starting, and I'm going to continue to go there. And I mentioned in a previous video that I'm working with, I have no idea how to say this library, but I think it's either ASMP or ASMP or something like that. It is just a way to import 3D files. So I have a FBX file that's generated from Blender that contains the main character Adam's model and his mesh data, vertex buffers, and things like that. And I'm not a huge fan of this library, just with how it returns things. I can't pass it a pre-allocated pointer. It's allocating memory on its own, which kind of defeats the purpose of having my own memory allocator. Like, even the STB library that loads images can do that. Like, it gave me the courtesy of just being like, hey, do you have a pre-allocated buffer that you would like to put the image data into? And I can just pass it in, and it does it. I wish, like, if there's anybody on, that works with that library, please, if there's a way that you could just, tell me how much data do I need, or how much memory do I need to set aside for you to do your work, and then just let me pass it to you. I don't want you to manage the memory for me. I don't know what you're doing under the hood without me having to just really dig into your code. It would inspire a little bit more confidence that you're just filling out data and not doing allocation festivals in the background when I'm just trying to get data out of a file. So there's that. But anyway, that is totally fine in the long run, because it's going to be a future feature that I'm going to have an asset table or multiple asset tables of, like, just big files that, I take assets out of files like, JPEGs or 3D model files like FBX files or WAV files for sound and stuff like that, and they're going to be transformed into data that the game will understand, right? If I was just reading them from their raw files. But to speed up the process of getting things off the drive and into memory, I'm going to put together tables that contain serialized data, exactly how the reclaimer, the game, will need to read it and understand it. So, like, for loading a bitmap texture like Adam's texture or the skybox back here, I won't have to, like, read it and parse it and do all this, that, and the other. Instead, there will just be a single header that will be universal for all asset types, whether it's an image or a 3D model or a sound file. It'll just say, here's the starting point in this file where the asset is located, and here's how large it is. That's it. And also, here's the type, whether it's an image, a sound, whatever. And you just allocate a pointer that is exactly that big, and you just serialize that data directly to the structure, and bam, it will work. That will speed things up dramatically. And also, I will plan on putting together a thread pool for threads for multi-threading things that aren't dependent of each other. For instance, there's no reason that Adam's asset should have to wait for the skybox to render, or vice versa. So that will be an interesting topic for later multi-threading. And that is basically it for this update. I know I spoke for a long time, but I have just been having an absolute blast working on this so far, and just thought I would update just how the progress is going. So yeah, there's that, and if you've made it this far, thank you so much for tuning in. And I'm thinking about doing my first live stream maybe like at the end of December, after Christmas. Like maybe we will take a look at building one of those asset tables, or implementing thread pools, or it's just going to depend on what the state of the game is at the time. At some point, I would really love to run a profiler on this and just find other bottlenecks in performance to remove. Ultimately, it's my goal that I don't know how close I can get to this, but like in terms of like theoretical benchmarks, if I could get the reclaimer to like load as fast and as long of a time as it takes to load the largest asset file, if that makes sense. For instance, I could get, loading assets down to a science, but, I'm not going to be able to get any faster than like however long it takes to load the largest asset. But I can optimize things and multi-thread things to the point where it's like I could make the load time as close to however long it takes to load the largest asset, and then just bam, it's just running instantly. I don't know how close I can get, but I'd like to try my best. And I know that, there's going to be other factors that increase performance load and things like that. But right now, I'm really happy with how things are running. It's nice and snappy. I can do what I want. And, like we saw earlier, the performance on this machine is a bit tanked. OBS is robbing a lot of my resources right now for recording high-definition video. I will do what I can to get a capture card for my laptop so I can just record things on the laptop, and so this isn't affecting performance in any way. But anyway, I'm Sam, again, the Reclaimer Dev. Thank you so much for tuning in, and I'll see you in the next video.